Hello, it's me, Hannah. I'm Hannah. I brought my grandkids, grade 2, science projects here. So interesting. So I'm curious about the experiments. So I wanna read outside. The outside. It's fun to work and think, make a splash and mix it up, physics, tricks, explore and record, never stop learning. So I wanna never stop learning. So that's why I'm gonna read and share with you. Magic? No, it's science. There are kind of usually these days, the magician uh, uh, use the kind of science and the practice lots of times. I heard that one of my country, the famous scientists, the practice from there, the the uh, youthhood, and after the 5 year more, 10 year more, they gonna be a kind of magician, and they show their magic show in the famous stage. So let's go science projects and experiments. The note to parents: some of the experiments can be a bit messy. Please be sure your little scientist is well uh, supervised supervised while performing the following projects and experiments. Have fun. Yeah. Here is make a splashy experiment number one. There are number four, I guess. Growing gummy bear. Growing gummy bear here. Make the growing. What you need: a small cup of water, gummy bear, candy, ruler, exert timing overnight. Yeah, it just suck this, gummy bear through the night. It will be swollen more, bigger than there. What do you think will happen when you leave a gummy bear in water overnight? Can you guess? In science, this kind of guess is called a prediction. Prediction. The steps we take to see if a prediction is accurate, correct, are called an experiment. When you do an experiment, it's important to follow the directions carefully and to watch closely to see what happens at each step. Circle your prediction. There are A, B, C. A, the gummy bear will get bigger. B, the gummy bear will get smaller. C, the gummy bear will stay the same size. Yeah, you're gonna circle about these directions. There are 7 directions. Before, first measure the length and the width of your gummy bear. How much length and how much width, top of to bottom and side to side. And second, draw an outline of your gummy bear in the before box. And number three, put the gummy bear in the cup. Number four, fill the cup with enough water to cover the gummy bear. 5, let the gummy bear soak in the water overnight. 6, check the gummy bear in the morning. 7, draw an outline of your gummy bear after the experiment in the after box. Here, there are the prepare, the gummy bear. Whatever. This one, cup and gummy bear and the measure, and make the before and after. You're gonna write here. String of spikes, make a spreadsheet. The Osmosis strikes again. Osmosis strikes again. String of spikes. If you did the growing gummy bear experiment, you know that osmosis is the way that water tends to move from wetter place into drier place. Now we will see what happens when the water being moved by osmosis isn't just plain water but has something else dissolved in it, mixed into it. Yeah, what you need, 7 inches of cotton strings like this here, and baking soda, and the 2 plastic cups and water, and the tablespoon. Resulting timing is just 2 days. The directions here, there are 5 directions. First one, fill the plastic cups with water. First, plastic cups with water, and second, add 1 teaspoon of baking soda into each cup, and number 3, put on end of the string in one cup and the other end of the string in the other cup. Number 4, let the string and the cups sit for 2 days. Do not stir, shake, and then wiggle, or do anything else to the cups while you are waiting. And number 5, after 2 days, check on the experiment. What do you see? Yeah, draw a picture of what the string looked like before the experiment and after the experiment. Yeah, we're gonna do it with my grandkids, and you draw here and there. And their answer also, you're still waiting, and then you're gonna go get this kind of experiment with your family. And there, make a splash experiment number 3 here. Colorizing plants, what do plants need in order to grow and be healthy? Put a check mark next to each correct answer. First, the sunlight, and second, air, water, the right temperature, soil, cupcakes, room to grow. And okay, cupcakes were just on the list to see if you were reading carefully, but the rest are all correct answers. Have you ever wondered how plants pull water out of the soil with their roots and send it up into the rest of the plant? Try this and you will see how it works. What do you need? Tall, clear glass or vase water, base water here, and then red or blue food coloring. Use liquid food coloring, not the gel kind. Long piece of celery with the leaves still attached. Result timing overnight. This one also overnight. You gonna put into the water like that, and after that's gonna change it, and you draw here the light, the color, more light or more deep, like the dark, green. Like there are directions 5. Number 1, color the celery how it looks before you start the experiment. And number 2, fill the tall grass with water. Number 3, add a few drops of red or blue food coloring to the water. Number 4, put the celery in the water and leave it there overnight. 5, in the morning, take a look at the celery. What's different about the celery after being in colored water all night? Color how the celery looks now. Yeah, color. You color. And freeze. Number 4, experiment. Make a splash experiment. The freeze and the frost. Yeah, freeze and the frost here. So interesting and so curious. So we're gonna do all the kind of play, the freeze and frost. I have curious about in this, the ice. Frosty in the thin layer of ice that forms on grass, trees, cars, and other things when the weather turns cold. Why do you think this happens? Yeah, I have interesting about that. And you just write on here the empty box. Let's make some frost inside the house so we can see how it really works. And there are what you need. First, metal coffee can with plastic lid, empty one, clean and dry one, or a small stainless steel mixing bowl, plastic wrap, and a rubber band. 8 to 10 ice cubes, 1.5 cup of half cup of salt, spoon. Resulting time is just 30 minutes. You make an ice, ice cream too. Yeah, after this experiment, with your mommy. The directions, there are 4 directions. Put the first one, put the ice cubes in the coffee can, and then 2, pour the salt on top of the ice cubes, and then use the spoon to stir the salt and ice a few times. Number 3, put the lid on top of the container or cover it tightly with plastic wrap and a rubber band around the lip of the container. Number 4, let the can sit on a table or counter. Check back in 10 minutes and again at 20 and 30 minutes. Do you see anything happening on the outside of the container? Yeah, do you see here and there? You're gonna write on here 10 minutes after, 20 minutes after, and 30 minutes after. So there are, you can see what the difference between the times. Yeah, and let's go to the next one. Next one will be the invisible skin. Yeah, the number 5. Did you ever, did you ever, did you ever wonder how polar bears are able to survive swimming in the freezing cold waters of the Arctic? It's because of this simple fact. Water and oil don't mix. Water and oil and don't mix. I put on here. So what you did, 4 to 6 drops of vegetable oil and water faucet and a liquid or bar soap for hand washing. And the result time just 10 minutes. You can discern and distinguish it about the difference of the water between the water and oil. And the directions here, soap and veggie oil and water only you need, and then just 10 minutes. Directions. There are 3 directions. Number 1, holding your hands over a sink, put about 4 to 6 drops of oil into one hand and then rub your hands together. And number 2, and turn the cold water on and let the water run over your hands. What happens when the water touches the coating of oil on your hands? On the illustration, draw how the water looks on your hands. Number 3, rub some soap into your hands and put them back in the water. What happens when the water touches your clean hands? What happens? Yes, there are number 6, super soapy boat. Super soapy boat on here. So you can also make a splash experiments. What you need, the index card. Here, the index card, like this one, we call the index card. And the 3 and 5-inch piece of manila file folder or cardstock. Scissors. Think for a large rectangular baking dish and water, liquid dish detergent. Result time is just 1 minute. Just 1 minute you can find the result. And direction. There are 4 directions here. First one, draw the outline of a rowboat on the index card, pointed at one narrow end, squared off at the other end, like this. There are draw out just outline of robot. And the number 2, the sink you are using for the lake must be clean before you start, with no leftover dirt or soap in it. Fill it half full of water. Number 3, place the boat gently on top of the water at one end of the sink. 4, squeeze a few drops of the dish detergent into the space. Where do you cut the notch out of the end of the boat? What happened out of the notch? Yeah. Yeah, what happened? Yeah, there are water everywhere. Look up, down, forward, backward, and diagonally to find these words. You can find this word and make a puzzle like this, You can find this word. Prediction water, osmosis. I don't know exactly about the osmosis, but I already read one here. The osmosis is this kind of cup, or there is the osmosis. String of sparks. The rope. There are also you know that osmosis is the way that water tends to move from wetter being. Yeah, and this place. I'm sorry. Surface tension, salt dissolve, molecule, and water vapor, evaporation and condensation, capillary action, observations, buoyancy displays. There are anyway some of difficult word here, but you can easily find what the meaning of that. Make a splash experimental explanations is just number one, growing gummy. Just listen about the six, experiments, explanations. The gummy bear grows bigger because it sucks up water. This process is called osmosis. This is osmosis. Bigger sucks up water. This process is called osmosis. Water naturally moves from areas that have a high water content to areas nearby that have less water. Osmosis tries to balance wetter areas with drier ones so that there isn't as much of a difference in the water content between the two areas. A gummy bear contains very little water. When you put it into a bowl of water, the dry gummy bear attracts water and grows as it holds more and more water. That will be the process osmosis, Number two, string of spikes. The water is attracted to the string because the string is drier than the water. It brings the baking soda with it, gradually soaking higher up the string. The baking soda collects on the string and forms small clumps or spikes. Number three, colorizing plants. When a plant's roots grab onto water from the soil, or like our celery from water, they are standing in the narrow tubes in the plant stem, kind of like drinking straws, carry the water upward to the other parts of the plant. This is called capillary action. Capillary is a very narrow tube. Capillary action. Very narrow tube is the capillary. Since water molecules stick together, each tiny bit of water that enters the tube at the bottom of the plant pulls up more water molecules with it. So that's why another way to see capillary action is to hold up a paper towel while dipping on corner of it into a small puddle of water. What happens? The water climbs up into the dry parts of the paper towel. The water molecules are sticky and tend to stay together, so more and more water is pulled into the paper towel, spreading even into the areas that didn't touch the puddle. Try this. Do the colored water experiment using a white carnation or daisy. write down your prediction first and compare it to what actually happens. The number 4, freeze and frost. You should see frost forming on the outside of the container, starting at the bottom within 10 to 20 minutes. If the ice cubes are on the inside of the container, why did the frost ice form on the outside of the container? It's because of a process called condensation. That's also the kind of process called condensation. Even when there's another cloud in the sky, there is water we can't see, water vapor in the air around us. As the temperature cools, some of that invisible water vapor changes into liquid water that we can see and touch. In our experiment, the ice causes the size of the container to become much cooler than the air around the container. This cooling caused the water vapor to change into liquid water, where it touches the container and then to freeze, forming a coating of frost. That's the kind of coating of frost. So we can see the freeze. So that's why, have you noticed how the outside of a glass sometimes feels wet after you pour a very cold drink into it? It's not because the drink is leaking through the glass. Instead, since the drink makes the glass cooler than the air around it, some of the water vapor in the air condenses, turning into liquid water on the outside of the glass. Wow, so interesting. Yeah, there are make a splash experiments here. My ear is still weird now. The number 5, invisible skin. The water is made of extremely tiny pieces called molecules. The molecules of water stick together very tightly. The molecules that make up oil are arranged differently from water molecules. So when they are put together, the oil molecules won't easily mix into the water. You probably noticed that the water rolled off your oily hands, the oil being the invisible skin, rather than washing the oil off with it. The water molecules stick to the other water molecules rather than grabbing onto the oil molecules. So that's why now you know why polar bears don't mind swimming in freezing water. Their fur is very oily, and so it acts as a kind of waterproof coat to keep the water away from their skin. The number 6, super soapy boat. At first, the boat sits on top of the water without moving. The tiny molecules that make up the water stick together very tightly, so they form a kind of invisible skin on the top of the water which holds the boat in place. This invisible skin is called the surface tension. When you add the dish detergent, the detergent breaks up the surface tension and the boat zooms ahead. Wow, it's similar like the detergent, the wash the outside of the dirt, and like the oil and water, the mixed kind of science like that. There are notes here. Do it yourself blue glue. Yeah, this one. I can try to read all of this, but I gonna divide the 2 times because my tongues are dry. My tongues is dry. Yeah, number 7. Do it yourself blue glue. Cornstarch is a white powder made from, you guessed it, corn. In cooking, the user job of cornstarch is to make a liquid mixture thicker. So cornstarch is a common ingredient in recipes for sauce, puddings, and gravies. What do you predict will happen if cornstarch is mixed with water? Yeah, your prediction first. Your prediction here. And let's find out if you are right. Roll up your sleeves and get ready to do some squishing. What do you need? First, 1 cup of cornstarch and half cup of water, blue food coloring, liquid food coloring, not the gel kind, mixing bowl. Result time only 5 minutes. Like this, you prepare this one. And the directions, there are 4 directions. And for pour 1 cup of cornstarch into the bowl. 2, slowly pour half cup of water into the bowl. And 3, add a few drops of blue food coloring to the mixture. And number 4, use your hands to squish the water and the cornstarch together. Don't be tempted to be neat and use a spoon. This experiment works best if you get your hands into it. Yeah, hands into it. Number 8, magic balloon. With this magic mixture, you can inflate. Yeah. Blue jay. Its voice a little bit cracked. Yeah, nah? The outside blue jay so beautiful. What is coming? Yeah. It just say to me. It says to me, I'm coming here. So let's play together like that. On the ground, it just cracking, make the voice. I just always call it JJ, blue jay, like that. Yeah, with this magic mixture, you can inflate a balloon without having a blow air into it. This experiment can be a little messy, so set it up near the kitchen sink and have some paper towels handy for cleaning up. What you need: small water or juice bottle, empty and rinsed out. The top should be small enough that you can stretch the opening of a balloon over it. Latex balloon, new one, and 4 tablespoons vinegar and 2 tablespoons baking soda, 8 and 8.5 and 11 sheet of paper or small funnel. This is helpful for getting the baking soda into the balloon, like this. And there are directions, 5 directions. First one, number 1, pour the vinegar into the butter. Number 2, using a small funnel or funnel or a piece of paper rolled into a cone. Spoon the baking soda into the balloon. 3, holding the balloon so that the bulb flops to one side so that the baking soda doesn't tip into the butter. Stretch the opening of the balloon to fit over the neck of the butter. Number 4, slowly lift the balloon and tip it down so that the baking soda falls into the vinegar in the butter. What happens? 5, draw pictures of the balloon and the butter as they looked before the experiment and after the experiment. Number 9, emerald seed pennies. Do you know the story of the wonderful Wizard of Oz? When Dorothy the Scarecrow, the Tin Man, and the Cowardly Lion arrive in the Wizard's Emerald City, they find that everything's green and the houses, the streets, the clothing, the people wear, even the pennies are green. You can make real pennies turn green and you don't need to borrow Dorothy's green eyeglasses to do it. All it takes is a little vinegar and a little patience. Hey, here. Yeah. What you need? Paper towel to clean shiny pennies, and vinegar about quarter cup vinegar, small bowl, and result timing overnight. During the overnight, your coin will be turned to green. The direction, there are 7 directions here. So the first one, the draw and color a picture of the pennies. What color crayons or markers come closer to the color of the real coins. Second, fold the paper towel in half and then fold it in half again into a square. 3. Put the folded paper towel in the bottom of the bowl. 4. Slowly pour vinegar into the bowl until the paper towel is completely soaked. There should not be a puddle of extra vinegar sitting on top of the paper towel. 5. Put the pennies on top of the wet paper towel and leave them there overnight. 6. The next day, take the pennies out of the bowl. How did they change? Did they change on both sides or only one side? 7. Draw and color the pennies the way they look now. What colors, crayons or markers do you need this time? What color? You can change the color too. And group 11. Next, mix it up. Yeah, there the part of mix it up. The first one, make a splash experiment and mix it up experiment. Groovy globes. Have you ever seen a lava lamp? Large colorful blobs of liquid flow to and fro as the lamp container is warmed by a light bulb or tilted back and forth. Lava lamps are fun to watch. They are also a demonstration of how inventors can use a science fact, such as water and oil don't mix, to create something new. You can make your own groovy globes container without a light bulb to see how those blobs of lava stay together. Yeah, lava stay together. And what you need, 1 empty 2-liter plastic soda bottle, wash it and rinse it with the cap, and a large bottle of vegetable oil, water, food coloring liquid, plastic cup, spoon, funnel. This is helpful for pouring things into the soda bottle without spilling. Yeah, here, like this, funnel. And the result timing is the 10 minutes overnight. 10 minutes there, you can, and overnight too. And the directions 5 here. And 1, fill a plastic cup with water. 2, add a few drops of food coloring to the water and stir to mix it. Number 3, pour vegetable oil into the empty bottle until it is half full. 4, add the colored water to the soda bottle. 5, put the cap on the soda bottle. Ask a grown-up to make sure the cap is on tight. Don't stir or shake the bottle, at least not yet. Yeah, at least not yet. And the 6, gently turn the bottle on its side. 7, draw and color what the water and oil look like now. Wow. Yeah. 8, try the variations in the chart. Draw the color your observations. There are empty box on your observation after this. Yeah, try this. First, with the bottle on its side, tilt it gently back and forth. What happens to the water and the oil? Yeah. Shake the bottle up and down to try and mix the water and oil. What do you see now? What do you see? Now, let the butter stand on the counter overnight. What do you notice in the morning? Now, what the contents have settled overnight. Turn the butter on each side again and gently tilt it back and forth. What do you see? Yeah, that's interesting. You're gonna go play with your family. Or the reaction here is when we mix things together and something happens to change those things or make something new, the process is called the chemical reaction. See how many words you can make using the letters in, the explanations. Wow, mix it up experiments. There are mix it up experiments still. Mix it up one more, the explanation. Oh, here, number 7, do-it-yourself blue goo. Blue goo. The particles of cornstarch are too large to dissolve, break apart, and disappear in the water. Instead, as you mix the cornstarch with the water, slimy strings of goo form. The goo is an example of a colloid, a special kind of mixture in which particles, tiny pieces of one type of material are suspended, floating in another kind of material. The particles are so small that you may not be able to see that they are actually separate from the liquid or gas in which they are floating unless you can look at the mixture under a microscope. Make sure that you tell your parents that the experiment was about making a colloid. That sounds a lot more scientific than telling them you made blue goo. More colloid mixtures, fog, water particles floating in air, and the milk, particles of milk fat are suspended in a water-based fluid, jello, particles of gelatin, flavorings, and sweetener suspended in water, oil point, particles of pigment color, and suspended in an oily liquid, mayonnaise, oil suspended in water with the help of egg yolks to keep the oil and water from separating, and the flavorings to make the mixture taste good on a sandwich. Number 8, magic balloon. When you mix substances like vinegar and baking soda, you cause a chemical reaction. It's hard to me, so because the almost 11 o'clock, 11 o'clock so, and then this will be gonna 38 minutes, so it is getting hot to me. So, and the magic balloon, when you mix substance like vinegar and the baking soda, you cause a chemical reaction. The chemical reaction changes the original ingredients in some way. In this, carbon dioxide is an invisible gas. We can spot it in two stages of this experiment. First, when the baking soda is dumped into the vinegar, carbon dioxide is produced and it makes the vinegar bubble. Second, the carbon dioxide rises through the vinegar into the air, where it's caught in the balloon. The reaction should produce enough carbon dioxide to at least partially blow up the balloon. So that's why, have you ever wondered why there are all those tickly little bubbles in soda? Carbon dioxide is squashed into the soda can along with the flavored drink. This process is called carbonation. The emerald seed pennies. The main ingredient in pennies is a metal called copper. It's the copper that gives pennies their reddish-brown color. Vinegar contains a chemical called acetic acid. When acetic acid touches copper, something new is created, a green-blue chemical called carbon acetate. In science, we call this kind of change a chemical reaction. The chemical reaction, the chemicals in the vinegar and in the copper react change when they are combined, making carbon acetate on the penis. Continue page 20. There. Explain. Did you notice that the top sides of the penis changed color but not the bottoms? That's because this chemical reaction can only happen if something else is available. Oxygen from the air around us, the tops of the penis are exposed to the air, and so oxygen is available to be part of the chemical reaction. The bottoms of the penis don't change because they don't have enough oxygen next to them to make the reaction possible. Number 10, crashing colors. Just like water, milk is made of molecules, tiny pieces that stick together. They stick so closely that when you put in food coloring, the food coloring for the most part just sits on top of the milk. Scientists call this trick surface tension. The molecules stick together as if there is an invisible skin across the top of the milk. When you add detergent to the milk, it pulls the milk molecules apart so that surface tension is weakened. The milk and the detergent molecules move around, and so does the food coloring. Where the colors mix, you may see a little green, orange, or purple. 11. Groovy gloves. The science fact we are working with here is that oil and water don't mix their molecules. The small particles they are made of don't fit together well enough for them to stay mixed together. Even when you shake the butter up and down, the oil blobs become much smaller when you shake the butter. But when you stop shaking the butter and let it stand still for a while, the oil bubbles start moving back together to form bigger globes again. Left on the counter overnight, the oil and water will have time to separate almost completely. You will see that the colored water sinks to the bottom and the oil forms a layer on top of it. The oil rises to the top because it is less dense than the water. Density is how much the object weighs compared to the volume of the space it takes up. In other words, if you have the same volume of water and oil, let's say 1 cup of each, the water weighs more than the same amount of oil. So you're gonna write on the note on here. Yeah, so that's why I'm just finished all the mix it up and make a splashy experiments. There are last one physics tricks experiments. That will be I gonna read on next video. My ear still ringing here and there. So thank you. So you enjoy the kind of experiments, and then you have you need to explanations, and there are lots of you are around. You make the kind of beverage or so the lots of scent and smells and then taste and then looking good, colorful drink or kind of candies or biscuits and bread, the perfume. Yeah, that's gonna be turned to the other, forms of our uh, around, but it still knows that we need to know about that. Good for our health. I watched it this morning kind of document about the popcorn smells and the perfume smells uh, make the terrible, you know, turn to terrible, to our body, our, yeah, like that. So you go to know first and what is good or bad. So you can uh, discern about the difference between good and the bad, and then good and evil too. Yeah, thank you. Because it makes the lots of products, and they gonna earn the money, and then some it's just attract us, and we eat and drink and the smell around us, and even the kind of candles, scent smells, scent the artificial, flowers like that. It makes us harm to our family, our society. So that's why some countries prohibit the kind of smell, the perfume, even the soap and the detergent. Yeah, see you. I just understand not all, but I just guess. But I compare with that documents film. I still remind them. Yeah, thank you. Just come the because of the nature, the breeze and trees and the skies, the so cool air and the fruits. So that's enough, to love our families and neighbors and friends like that. So the artificial make us convenient, comfortable, but there are the both go together. The harmful trashes, waste time and spend money, and not go to the people, go to the only selfishness. It fear our selfishness. It's more lazy like that. So we have to know the kind of science, but if it goes to the bad, the not good side, to bad side, then we need there are kind of solutions of the result of science. We need to know about the truth from God. God created all the beautiful circumstances for us to love, to share, to happiness, to know more about the beauty. How do you know about the beauty? Through the science, the result, not just naturally, automatically we love to other, then we can share with others and we can love each other. Yeah, not exactly through the science, but we just accept this sweet, beautiful breeze and the air and eat the natural fruits and vegetables. Yeah, I want to, after the more read, and then we talk about that with the kids, grandkids. Yeah, bye. See you soon.